Choosing the right camera depends on the need and preference of human being. There are two types of technologies nowadays, for example, cell phones and reflex cameras. As we know that cell phones offer unparalleled convenience with always on-hand availability, user-friendly interfaces, and instant sharing capabilities. On the other hand, most of the professional photographers prefer reflex cameras, DSLRs, that provide superior image quality and versatility. The principle of optics, wave, and modern physics on comparing features of camera and how does this affect user choice from physics belief will be explored throughout this project-based learning. So the comparison between cell phone camera and reflex camera is to determine whether both options can produce equal quality of pictures. The method that we use is 3-step cycle to make sure the discussion goes well on what we do, what do we need to know, and make summary from each part. In results, the data observed is to make comparison of cell phones versus reflex camera DSLRs. Therefore, understanding the strength of each option will help people to make the best choice, especially in photography needs.
As technology advances, the demand for clearer, higher resolution images and videos has increased, driving the evolution of both cell phone cameras and also DSLRs. Cell phone cameras leverage principles from optics, wave theory, and modern physics, employing small lenses to focus light onto CMOS sensors and utilizing concepts like focal length and aperture to capture clear images. Light wave behavior, including reflection and refraction, is essential for lens design, with anti-reflective coatings reducing glare and also improving image quality. Similarly, DSLRs utilize advanced optics and wave theory, with lenses focusing light onto image sensors like CMOS or CCD, converting light into electrical signals via the photoelectric effect. Advances in semiconductor technology continuously enhance sensor performance, leading to better image quality across various lighting conditions. The decision between a DSLR and a phone camera hinges on individual preferences, considering factors such as image quality, versatility, and its convenience.
For the problem statement, smartphone has become an indispensable part of daily life, integrating functions such as camera, agenda, GPS, and gaming console into a single portable device. Despite the convenience and multifunctionality of smartphones, there is a question of whether their photographic capabilities can truly rival those of professional cameras. Many people rely on smartphones to capture important moments due to the ease of use and instant sharing capabilities. However, professional photographers continue to invest in high-priced, less portable cameras such as a DSLR Canon EOS. This raises the question, is the price difference between a professional camera and a smartphone justified in terms of photo quality and functionality? To address this, we will analyze and compare the physical features and performance of a professional DSLR camera, the Canon EOS, with those of a smartphone, the iPhone 4S, focusing on specific physics principles that affect photography. This analysis will help determine whether the investment in a professional camera is warranted and provide insight into improving photo quality with each device. The objectives are to use the understanding of principle of optics, wave, and modern physics on comparing features of camera. Second, to explain how features of camera affect user's choice from physics points of view. Third, to determine whether a cell phone camera can produce photos equal to those taken by high-end reflex camera.
Next, I will be explaining the literature review. So, the debate between cell phone camera and DSLR camera is driven by advancement in technologies and user preferences. Studies highlight that cell phone camera, enhanced by AI, offer convenience but are limited by smaller sensor and simpler lenses, which affecting image quality, especially in low light. In contrast, DSLR camera are praised for their superior image quality and versatility, featuring larger sensors, interchangeable lenses, and extensive manual controls. Research shows that DSLR have better anti-reflective coatings, larger pixels, and broader aperture settings, which provide sharper image and greater creative options. Both types use polarizing filters, but DSLR often do more effectively due to advanced optics. Despite the convenience of cell phone camera, professionals favor DSLR for the image quality and creative flexibility. The literature indicates a need for further research on how emerging technologies might enable cell phone cameras to match DSLR in professional setting.
Moving on to the methodology, the purpose of this project is to compare the characteristics of a reflex camera with the camera in a cell phone through discussing the physics concept relating to features of a camera. These are the 10 questions that are discussed throughout the online discussion conducted and will be explained in the result and discussion.
Alright, now I'm going to discuss about our result. Firstly, anti-reflective aka AR coatings reduce the quantity of light reflected by camera lenses by manipulating both the refractive index and phase shift of the coatings. Additionally, the AR coating is designed to be a quarter of the wavelength of the target light in thickness, creating a phase shift that causes destructive interference between the light waves reflected from the top and bottom surfaces of the coating. This destructive interference effectively cancels out reflected light, significantly reducing reflections and allowing more light to transmit through the lens. The overall phase difference between light rays reflected on an AR coating and those on the lens is influenced by several factors, one of it being the thickness of the AR coating is typically designed to be a quarter of the wavelength of the target light within the coating material. The specific wavelength of the light being targeted is crucial as deviation from this can alter the phase relationship and reduce the coating's efficiency. Additionally, as the angle of incidence increases, the effective optical path length through the coating changes, which can shift the phase difference and potentially diminish the destructive interference. As mentioned just now, not all light refractions on any interface always have the same effect on the phase of the reflected wave in comparison to the incident wave. This is because the phase change of light when it reflects depends on the refractive indices of the materials involved.
Moving on to the effects of pixel cells on the size of airy disc. When the airy disc size reaches the pixel size, the lens opening can be considered as the sweet spot. If the airy disc size is larger than the pixel size, it can lead to difficulties in achieving the full resolution capacities of the sensor with usable contrast. When pixels are too small relative to the size of airy disc, more information can be captured by the sensor than necessary, which will lead to oversampling.
An airy disc is the diffraction pattern created by light passing through a circular aperture, featuring a central bright spot and surrounding rings. The Rayleigh criterion states that 2 points are resolvable when the distance between the centers of their airy disc equals to the radius of the central disc. The f-number or f-stop in photography determines the lens aperture size, controlling light entry. It depends on two main parameters, which are the focal length of the lens and the aperture diameter. The formula, which is d equals to f over f-number, is used, whereby d is the biggest possible aperture opening, f being the focal length and f-number being the ratio of the focal length of a camera lens to the diameter of the aperture being used.
After calculation, the largest possible aperture opening for the Canon EOS 5D is 50 mm, while for iPhone 4S is 1.604 mm.
To find the distance that we would be able to distinguish a hair 100 micrometers in diameter in photos taken by a Canon EOS 5D and an iPhone 4S is firstly by using the formula linear resolution equals to pixel diameter over square root of sensor resolution. And then, to find the distance, we divided the hair diameter over the linear resolution that was found.
The distance to distinguish a hair 100 micrometers in diameter for Canon EOS 5D is 43,668 pixels, and for iPhone 4S is 161,550 pixels. Moving on to the next slide, a polarizing filter can create photos showing skies that are bluer than reality through polarization by scattering. Besides, a polarizing filter can produce photos with no reflection from snow, glass, or water through polarization by reflection. For infrared filter, it does not work on the same principle of a polarizing filter. A polarizing filter blocks polarized light wave selectively depending on the orientation, while an infrared filter prevents infrared light specifically while allowing visible light to pass through.
In modern photography, the interrelated areas between optics, wave physics, and technology highly influence the consumer option for choosing between the cell phone camera and a reflex camera. Anti-reflective coatings are crucial for both types, as it enhances light transmission and reducing glare by creating destructive interference with the light waves, thus improving image quality. The efficacy of these coatings depends on their thickness, refractive indices, and environmental factors. The debate over the lens size highlights the trade-offs between light gathering capabilities, versatility, and portability, with larger lenses excelling at low light conditions and offering sharper image. The Iridis and Reliquatrillon emphasize the importance of aperture size and numerical apertures in achieving high resolution of image. Photographic filters, including neutral density, polarizing, and UV filters, modify light characteristics, enhancing contrast, reducing glare, and protecting the lens. Polarizing filters, by manipulating light polarization, effectively enhance sky color and reduce reflections, while IR filters ensure accurate color reproduction by blocking unwanted IR radiation. Overall, every aspect in photography plays into the complex considerations for photographers to deal with when making images that have the highest quality and aesthetic.